Hi, I'm Paul Madle. I'm a Senior Software Engineer working for KISPE. Kernow Sat is a really exciting Internet of Things satellite that's going to fly in space over Cornwall. It's going to collect data from remote buoys in the sea and relay that information to the ground. And those buoys are going to be collecting data like the marine conditions around Cornwall, which is going to be great for surfers and for marine scientists to get a much more greater understanding of what's going on in the sea around Cornwall. I think the innovation with this satellite is really around what we're doing in the community of Cornwall. So we're trying to engage with colleges, universities and even schools in the development of the satellite, but also the buoy systems. So the idea is that we'll be going into schools and colleges and helping them to, or getting them to help us to develop the buoys that are in the sea around Cornwall. Yeah, so today's an exciting day because we now have our first piece of the Kernow Sat hardware, which is right here behind me. This is actually an engineering model, so unfortunately not quite the model that's going to fly in space, but nonetheless it's an exciting day because we have this first element of Kernow Sat, which is called an ADCS computer, or Attitude Determination and Control System. And this computer is used to help the satellite orient itself when it's in space, to make sure that it's pointing in the right direction. These wires are the first link between the ADCS computer here and what will become our satellite. So at the moment what we're doing is we're hooking up this ADCS computer to another computer which is helping us to write our onboard software. So we write our onboard software and we're checking that it can communicate well with the Cube computer. Yeah, so the critical design review is a really important step in the life cycle of the development of the spacecraft. And in our CDR, we've managed to get to the point where we know what components we need to buy, what components we need to develop, how they hang together, what kind of power will be generated from the satellite, what kind of power will be consumed by the satellite, what kind of environment the satellite's going to be in, what sort of orbit it's going to have around the Earth, and we're checking and validating and making sure that all of these factors hang together and make something that will actually work over the long term in space. Yes, so we've got a lot of know-how in-house that will help us to ensure that we've developed a spacecraft that can survive the thermal environment of space, because that's quite extreme, the radiation environment of space, so ensuring that the components that we have on these printed circuit boards here can survive the space environment from a radiation point of view, and knowing that the spacecraft will have enough power to do what it needs to do, and that it can interface to all of these different boards can interface together and communicate together correctly.